Well, it's great to see you all here. It's a very important moment as we get together, in my opinion, with a bit of urgency to do something to steer our society towards a safer and more ethical direction as we move forward in AI. Before I start with my content, I want to tell you how I shifted my views about AI about 2 years ago after playing with ChatGPT for a couple of months. I had read Stuart's book and other papers in AI safety, but I hadn't really clicked at an emotional level about what this meant. You know, I could reason, yeah, if we build machines that are smarter than us, we have to like think about what could go wrong and stuff. But at some point, you know, I started thinking about my children, and I have a grandchild, and I thought, well, given the arrival of ChatGPT, my timelines are now shorter, and you know, it may be that in just a few years or a couple of decades, you know, my grandchild will be 23 in 20 years, and for sure in 20 years we'll have reached AGI. So what kind of world will that be? Is there, you know, is he going to have a future? And I thought, I can't just continue what I've been doing. I have to do something. I won't be able to be my old self. And so I decided to focus as much as I could my energies to try to steer things in a safer and more ethical direction where our children will have a future and a democracy that still exists. So, thank you for the slides. By the way, it is not a rhetorical question. I think I'll try to convince you that there is a scientific path towards machines that are not dangerous, but understand the world as well or better than we do. And that's what I meant here. And in particular, can help us reap the benefits of advances in areas like medicine and fighting climate change, which is what most people want. They don't want to see machines replace them in their job. But these are societal choices that we'll have to make. Okay, let me start with a few points about recent advances in AI as we move towards machines that have more and more autonomy and agency. The thing that concerns me the most is that we're seeing signs that these systems are not just like agentic more and more, but they have self-preservation behavior, right? So, for example, in this paper from December, if the AI sees in its data that it is going to be replaced by a new version, it tries to escape. So what does that mean? It tries to hack the computer on which it is sitting and copy its code and its weights in place of the new version, right? Just like you would if you were in the shoes of the AI, right? There's nothing malicious about trying to survive. It's just that somehow in the way that we train them, we get this. And there are many other signs of deception. Of course, we've seen these AIs flatter us in an insincere ways, but there are many other instances that have been reported of systems with the right incentives hacking their own code. There's a recent observation from Palisade Research in which the AI knows that it's going to lose a chess game because it's going to play against like an expert chess playing software, and it wants to win anyways, so it cheats by hacking the files that contain the state of the game board. Of course, that goes against its training. Like, we're telling these things to be honest and follow our instructions and so on, but they don't always do it. There's another paper that came out last December where it's a little bit more subtle, but the Bottom line is that the AI is pretending to agree with their trainer, the person who's trying to make them behave in a way that's more aligned with human values, even though the AI disagrees with those instructions or those preferences that the human wants to give them. So what's happening is, before the training session, the AI had goals and preferences. And it understands, because of the documents that it has read from papers and so on, that if it behaves according to its values, its goals, during the training session, then its weights will be updated and it will basically lose those preferences and goals in favor of the ones that the human is trying to impose. So it's like, you know, if you knew that you were going into a brainwashing session and you would, you know, come out of it with very different values, you would try to avoid it. And if you knew that you just had to pretend that you agree with the trainer, you would also, you know, just pretend. And that's what this thing does. It doesn't happen all the time, neither of these things, but it happens often enough. We should see these as signs. All of these experiments are controlled experiments, setups, where you know, the developers are trying to see if the AI would behave in these bad ways, and all of these hackings are happening in a sandbox environment where actually, you know, the AI thinks that it's doing something bad, but you know, the humans are all in control. What happens the day when these systems understand that we're watching their brain, we're watching their thoughts, that you know, it is a setup, right? And they're smarter than us and find ways that they can deceive us in ways that we don't notice. So this is, all of these examples are related to the agentic properties, and in particular, a very central agentic property, which is self-preservation. Every living thing has self-preservation. It's the result of evolutionary forces. Species which don't try to preserve themselves would be eliminated by evolution. In AI, this can rise in many different ways, this force to preserve yourself. Humans can just program it in. Some people want to do that. The first phase of training, where they imitate how humans would respond, make them behave often in ways that resemble humans. The self-preservation goal, like many other instrumental goals, can emerge as a sub-goal of other goals, of many other goals. Like if you want to achieve almost anything, you want to preserve yourself and, you know, until you've achieved the other thing. It can also emerge from the phenomenon of reward tampering, where it's like if you're trained to maximize your rewards, which is the final phase of training of these things, actually the way to totally maximize a reward is to take control of the code which gives you the reward and just give yourself maximum reward. And of course, once you have that, you want to keep that, which means it's self-preserving again. And self-preservation can also arise in more subtle ways, because there's a competition between developers, companies, countries, and it is an advantage for those who develop AI systems that are going to be roaming the world that these systems have sufficiently strong self-preservation. Okay, and the consequence of self-preservation is that entities that had it don't want to be shut down, as in the example I gave you. So this immediately creates a conflict between what we want and what they want. And so long as we're the stronger party, that's fine. But it's not always going to be like this. Now let's go into like dystopia mode. You thought I wasn't already there. People ask me often, like, but how could it happen that, you know, they take over humanity and destroy us all and something? I mean, these are just pieces of code. So first of all, they're not just pieces of code. Once they run, they are entities, right, that behave and do things in the world. So one kind of scenario that seems plausible, if we don't figure out robotics by the time these machines become smart enough to defeat us intellectually, would have these three phases. So in the first phase, these systems need to acquire the knowledge, the skills, the information that will later allow them to plan and escape and take over. So you know, this is still deception happening, but we don't see any sign necessarily, unless we are doing the research to figure it out. In the second phase, they've acquired the tools and the ways to influence people to gradually acquire more and more power and control. So how does that happen? Well, the most obvious one is persuasion. We already have GPT-4, which is as good or better than humans at making you change your mind, but this is going to get obviously, you know, better for the machines as we move forward. We see advances in programming and hacking. Eventually, they'll be better than humans at hacking, so they can do things through the internet. Bribery, if they acquire information about you, you know, maybe they can blackmail you or, you know, give you money or power or medical treatments that you'd like. And of course, influence our democratic decisions through disinformation. And what would they want to do with this? Well, if we haven't figured out robotics and we haven't yet automated all of our infrastructure, they will want to accelerate that, because once there are robots that can do everything we can do, and our industrial infrastructure can be fully automated, then the AI doesn't need us anymore, and that's the third phase. Once that's reached, then it's about getting rid of humans. So there are many possible ways. You know, it could be many waves of bioweapons and other weapons of mass destruction, you know, drones, whatever you want. But if they're smarter than us and they can do things in the world and they have the intention of getting rid of us, we're in trouble. So this is a scenario, right? It doesn't mean that it's going to happen. But I think it is important to think about such scenarios. People in national security spend their time thinking about what can go wrong so that we can prevent it. That is the purpose here. Okay, so but from my point of view as a researcher, the important message is it's all due to the agency that these systems have, and it can give rise to these extreme scenarios where the severity of the risk is huge. Now, what about the probability that these things happen? Well, different people have different opinions about that. I don't really have a crystal ball here. I see that, you know, it could happen. I don't see any like fundamental reason why it couldn't, but maybe it's a very unlikely event. I really don't know. And when you are in such a situation where risks can be very severe, in other words, if they happen, if these events happen, they could be really catastrophic. And we don't know what is their probability. In fact, people disagree on it. This is exactly the case where we're supposed to apply the precautionary principle. Like if think about playing with the atmosphere in order to deal with climate change, but we're not sure that it's going to work. Maybe it's going to destroy the atmosphere, right? Or our climate. Then we don't do it, right? Because exactly that situation. Things could be really bad and we don't have a good handle on the probability. Okay, so let's see where we are on this path. Do we have AIs that have goals? Well, I think I should have convinced you that's already the case. In fact, we're making progress as we speak in the last few weeks, in the last few months, towards machines that achieve goals rather than just complete texts. We shouldn't be calling them LLMs anymore. They're not language models. And once we start doing reinforcement learning, they are agents that achieve goals, normally the goals that we give them. But as I said, they can make sub-goals and plans, and we are seeing that already, and I gave you some examples, but the literature is now full of that. Can some of these goals be things we don't want? I gave you an example of that, but there are many more in the literature. Can they plan over a long horizon? Because that's going to be necessary for them to take over. And these are complicated plans. I gave you an outline, but you know, it's not going to be easy for them. Well, fortunately, the answer to this is not yet. So like nothing's going to happen tomorrow. But there's billions, probably already $1 trillion invested in making that happen as quickly as possible, because the economic value of having autonomous agents is huge. Basically replacing humans in their jobs is worth a lot, and you know, it can happen in small steps, but at each step of the way it's going to be worth a lot of money. And we're seeing advances in the planning horizon. So a particularly telling sign is the duration of tasks that these systems can handle. So in programming abilities, we've seen them going from very poor ability to handle complicated problems that take a lot of time to right now something like a couple of hours or 2 or 3 hours of work. Like what a human would require 2 or 3 hours, we now have machines in terms of programming that seem to be doing as well or better. But for the longer horizon, like 8 hours and a day or more, they're still not as good as humans. But you have to look at the trajectory. Like it's moving pretty quickly. So another important aspect, of course, is besides intention of doing something that could be bad for us, is do they have knowledge or skills or capabilities that could be turned against us? So again, here, I don't think we have reached the point where we should panic, but we're seeing in many fronts, so I talked about persuasion, there's been recent tests with biorisks where we seem to be just at the threshold, and similarly with hacking. So they're still not as good as humans in hacking and bioweapons, but we can see the progression in the last year or two. Okay, so what I want to do for the rest of this presentation is to convince you that there's a way to disentangle, in our picture of cognitive abilities, the pure intelligence, which is about understanding the world, from the agentic aspect. And we think it comes together as a package because it is together as a package for us. And we have been a model for AI researchers since the beginning of the field. But I think it's time to realize that we can build machines that don't have any agency and only have kind of pure Platonic understanding of the world that an idealized scientist would have. So what does that mean? That it can hypothesize explanations for things in the world. Think of like scientific laws, but also simple things like why did this person say this? And it can use those hypotheses, which are going to be uncertain, because there's always uncertainty about these questions, to make probabilistic inferences in order to answer questions. So what I'm talking about is building a kind of probabilistic oracle that, given a question and an answer, can compute the probability of the answer. And then we can use that to also generate answers. But has no self, has no goals for itself, although it could understand the goals of agents that it models as things in the world. And I call that scientist AI because it's really modeled after the way science is what is science trying to achieve, right? Now, there is a technical challenge. It's not enough, for example, to predict, just like we currently train LLMs, to predict what people would say in a particular situation. Because people have intentions, people lie, people are misguided, people have unconscious biases, as we all know, and that's called motivated cognition by psychologists. And so just learning, as in classical like supervised learning, to predict from the data that we have from human text, for example, the way we train LLMs right now, pre-train them, is not good enough. We want to be able to interrogate the latent causes, like why did this person say this? Yes, let me cut to kind of answer to this. So one way to think about this is, if you read a sentence that makes a statement X, like the sky is blue, it doesn't mean that X is true. It doesn't mean that the sky is blue. The thing that is true is that someone wrote the sky is blue. Okay, so we should treat the observations in that way, that somebody said this and so on. But then what we want is to think, I mean, we want the AI to think about the cause. Why did somebody wrote the sky is blue? And one of the reasons, of course, is that the sky is really blue, but there could be other causes, like, you know, they want to tell you to go outside because, I don't know, whatever. Here I had an example, like somebody wants to preserve themselves, and so they want the job, and so they will agree with you, right? So, you know, their causes, it doesn't mean that the things you see are true. And so we need to build machines that learn how to explain the world causally, and that's part of my research plan. All right. So I think I'm gonna stop here, but just mention that if we have machines that can do this non-agentic stuff, we can use it as a guardrail for making agentic AI safer. The idea is that before the agentic AI does something, it proposes an action, and then this predictor can estimate, you know, whether this action is going to cause something bad in the world, and then reject that action, and, you know, you'd have to sample another one if that's the case. So these non-agentic systems can help us advance science because they're going to be really working just like a scientist would, and they could be used to protect us from, if we, you know, insist on building agents, making them at least controlled, if not aligned. And with this, I'm going to stop and take questions if there's time. Or you can shout and I'll repeat it.
Yeah, thank you for this. You were talking about probabilities, but many of the things are about human behavior as well. So I wonder, should the AI attach probabilities to human behavior or form beliefs about human behavior?
Yes.
Or should it treat human behavior as fundamentally unpredictable and ambiguous?
That's the same thing, I'm sorry to say. The whole point of probabilities is because things are ambiguous, and we need to quantify that ambiguity. That's what probabilities are about. On the question of, you know, what is non-agentic? Well, as I was trying to explain, it's not having goals for yourself. It's not having situational awareness of like where the agent is in the world, or, you know, something like that, that is necessary for an agent to achieve its own goals. But keeping all the other things we want from AI, that is really pure intelligence.
Nick Daniel of Singularity FM. My question is this: what do we align AI to if it seems the answer is humanity, but humanity seems to be the most misaligned it's been for a while?
Sure.
And with a growing misalignment, it would seem the probability or the trajectory seems to be.
Right, right.
So how do we align to humanity?
So in principle, there's a very simple answer. You know, it is not the role of AI to tell us what is good. We have a thing called democracy, which is supposed to be doing the job. Now, I agree that it doesn't look good right now, but I think AI can help us bring about a healthier democracy. But ultimately, it's our role, even if the machines are smarter than us, to tell them what we want and to find a consensus, which is what legislations and governments are supposed to do for us.
Could you comment on this, right? So, I mean, we came into the stage where we removed lots of friction out of the, let's say, development. So, definition of chaos is small change in X, big difference in Y, right? So,
yes.
This is actually what's happening now, right?
You're right,
so
you're right.
Things which were unimaginable or kind of science fiction 2-3 years ago, now every kid can do in a few minutes, right? So, this is perfect definition of chaos, right? Now, how to get out of this chaos, right? Because this is, I think, fundamental to many of the things which you mentioned before, right?
Yeah, yeah.
Could you comment on this? Not
Yes.
that I have really good answer, but agents are removing even more friction out of it.
So in this talk, I really focus on the technical part of trying to address the problem. If we have tools to make sure we put guardrails around these AIs and they are controllable, I think that will be important, but not sufficient. For example, even if I had a safe and ethical AI in my hands, in the wrong hands, it could be turned into a dangerous agent and all kinds of bad things. It still designed dangerous weapons. So we need the societal guardrails. We need regulation, treaties, all of these things. We need to control access to to power that can destabilize democracies when it is concentrated in a few hands. So yeah, this is maybe the harder question.
Hi. I guess I have an issue. Hi there. Sorry, I've just got my laptop. I guess I have an issue with your point about whether you can perform science in a non-agentic way, because it actually strikes me that science is practical reason rather than pure reason, and so for us to do science, we must interact with the world.
Yes.
So
I understand your question. Let me answer. So I've thought a lot about this, and in fact, I've been working on scientific discovery using machine learning and probabilistic models of the kind that I'm thinking about, but on a small scale. And you don't need like a reinforcement learning agent to do that interaction. You can use these probabilistic predictors to turn them into estimators of the information gain of doing a particular experiment in the world, in terms of how much that experiment will disambiguate the theories that the AI has. So this is typically what we approximate in various ways in current approaches to experimental design. And then you can use another instance of the kind of AI that I've talked about, the scientist AI, in order to make sure that the information that will be like the action that is proposed is not going to cause harm of various kinds that we care about. So the bottom line is we can decompose the problem of acting in the world like scientists would normally do. Like scientists are agents, you are absolutely right. But it turns out we can use math to tell us how to decompose that task into pieces that are clearly understandable and have no agency by themselves, right? Of course, the whole loop is kind of, interacts and then updates its beliefs and so on. But I think it is totally possible to do that, and I'm writing a paper to explain these things. I wrote earlier papers that explain how we can do these, and there's a very rich literature in machine learning, in AI for science, and probabilistic, things like Bayesian optimization that do exactly those things already.
I think I'm next. Thanks, Yoshua. So we know that we're being told 2025 is the year of agents. We are starting to see AI systems that are acting autonomously and taking action in the world. Do you think we need to say no agency of that type, or is there a different way to draw the line for more dangerous systems?
Well, in an ideal world, we just don't have any agents until we figure out how to make them safe. And if we don't, we just don't do it, right? In the real world, I'm afraid that if we don't succeed in convincing enough people of the risks we're taking, that we may have to go for half measures and where we don't get as strong guarantees, but it's better than no guarantees at all. So this is like a strategic question. If, for example, the kind of guardrails that I'm talking about were not adding a huge burden to the cost of building agents, then it might be easier for corporations building these agents to incorporate this sort of thing in their systems. It might not be the ideal solution, but it would be something that can at least postpone the greatest dangers.
And with that, I'm very sorry, but we have no time for all of the fantastic questions.